हेलो हेलो वॉइस चेक हेलो नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार द्विशेट्टी, फैकल्टी ऑफ मेजरमेंट्स एंड इंस्ट्रूमेंटेशन। बेहतरीन प्लान से बहुत दिन के बाद पीडब्ल्यू से आ रहा है यूट्यूब क्रैश कोर्स। पहला सब्जेक्ट स्टार्ट हो रहा है मेजरमेंट्स। जितने लोग लाइव में हैं जल्दी से जल्दी ज्वाइन हो जाओ। ये 2 घंटे में हमने बहुत सारा प्रॉब्लम्स, गेट न्यूमेरिकल्स, कॉन्सेप्ट्स, फार्मूलाज पूरा डिस्कस करने वाले हैं। आपको पता है पीडब्ल्यू जो प्रॉमिस करता है वो प्रॉमिस हमेशा निभाता है, वो प्रॉमिस हमेशा फुलफिल करता है। सो last couple of days the YouTube crash course was started and many subjects are in queue, so जल्दी से जल्दी आप ज्वाइन हो जाओ। आपका जो गेट प्रिपरेशन हो रहा है वो गेट प्रिपरेशन के लिए ये आपको एक कैटलिस्ट होगा। यू कैन यूज दिस पर्टिकुलर क्लास एज प्रैक्टिस। जल्दी से जल्दी ज्वाइन करो बेटा। जितने लोग लाइव में हैं मुझे एक बार थम्स अप दिखाइए। आज हम स्टार्ट करेंगे मेजरिंग इंस्ट्रूमेंट्स पार्ट 1। 4 लेक्चर्स लाइन में है, फटाफट मेजरिंग इंस्ट्रूमेंट्स 1 2 3 4, उसके बाद एनालिसिस। ओके, सो या नवंबर 5 से स्टार्ट होके नवंबर 10 तक ये क्लास चलेगा। एवरी डे मॉर्निंग 7 बजे। जल्दी से जल्दी आप अलार्म रख दो। एवरी डे यू कीप एन अलार्म। मॉर्निंग 6:30 यू कीप एन अलार्म, गेट रेडी, हैव ए कप ऑफ टी, फ्रेश टी एंड कम बैक टू द यूट्यूब क्लास। सो जितने लोग लाइव में हैं आप एक बार थम्स अप दिखाइए एंड आपका ब्रांच भी नोट कर दीजिए। यू आर फ्रॉम विच ब्रांच? You are from which branch? Are you from electrical or are you from instrumentation? So these topics can be suitable for electrical and as well as instrumentation. चलो my dear, lecture number 1 measuring instruments है। Topics to be covered: types of instruments, what is the types of instrument, next PMMC, torque and its formula। इस क्रैश कोर्स है, फटाफट एक सिंगल शॉट से हमने फॉर्मूलास लेते हैं, डेरिवेशंस ज्यादा नहीं देखते हैं, हम फॉर्मूलास लेते हैं। फॉर्मूलास के बाद हम डायरेक्टली प्रॉब्लम्स को चले जाते हैं। ओके, सो PMMC टॉर्क फार्मूला, रेंज एक्सटेंशन एंड इट्स PMMC, मूविंग आयरन इट्स अ टॉर्क फार्मूला, रेंज एक्सटेंशन ऑफ मूविंग आयरन। समय बहुत कम है, 2 घंटे में हमने ये टॉपिक्स कवर करने की कोशिश करेंगे। फाइन बेटा। या शाहिद हुसैन शेख इज देयर, चरण इज देयर, कल्याण चक्रवर्ती कैसे हो, उमेश ठाकुर कैसे हो, रियार अहमद, आदर्श राज, everybody, Deepu Rana, nice to see you all, nice to see you all. Okay, so let us start first. Basically, what are the instruments we have? Let us see, these are different types of instruments, my dear. These are the different types of instruments. PMMC, permanent magnet moving coil, next moving iron, electrodynamometer, majorly electrical syllabus, permanent magnet moving coil. So first let me talk about some syllabus. Why? Because many of the people are confused. So syllabus का width कैसा होता है? So let me talk about something about the syllabus first. Syllabus blueprint for gate measurements. Gate measurements. Okay. सो गेट मेजरमेंट्स का सिलेबस कैसा होता है? अरे पुष्पेंद्र पटेल, अभी तो मेजरमेंट स्टार्ट हो गया, मेजरमेंट्स पर ध्यान रखो बेटा। आईएन सब्जेक्ट्स के लिए क्या सोच रहे हैं? आईएन सब्जेक्ट्स रखे तो रखेंगे, नहीं तो नहीं रहेंगे। अब तो इंफॉर्मेशन है मेजरमेंट्स के लिए। सुमलता जी गुड मॉर्निंग, कहां से हो आप कहां से हो? पहले बार आपको देख रहे हैं मेरे लाइव क्लास में। यू आर फ्रॉम तेलुगु स्टेट और व्हाट? सुमलता, इट्स अ तेलुगु नेम राइट? या पुष्पेंद्र पाटिल जी, इंस्ट्रूमेंटेशन के लिए क्लासेस यूट्यूब रहेगा नहीं रहेगा अब तक तो क्लैरिटी नहीं है, रहेगा तो मैं ले आऊंगा, डोंट वरी अबाउट दैट। सो लेट अस टेक द सिलेबस, ब्लूप्रिंट सिलेबस ब्लूप्रिंट। इज द कलर इज ओके? या इलेक्ट्रिकल। सो मेजरमेंट्स का सिलेबस कैन बी कैटेगराइज्ड इनटू 3 ways. Measurements का syllabus for gate is categorized into 2 ways, sorry. One is the electrical measurements, other one is the electronic measurements. Is electrical measurements other one is the electronic measurements. Electrical, next comes electronic. Okay, what? Electrical and electronic. In electrical measurements, what we are going to take? Good morning my PW school, thank you sir, good morning. Hyderabad sir, Hyderabad से आ गया, कैसा है हैदराबाद? हैदराबाद बिरयानी इज वेरी फेमस ना, हैदराबाद बिरयानी, ईरानी चाय, चार मीनार बहुत फेमस है हैदराबाद में. ओके चलो, इलेक्ट्रिकल मेजरमेंट्स में क्या क्या आएगा? फर्स्ट इलेक्ट्रिकल मेजरमेंट्स में मेजरिंग इंस्ट्रूमेंट्स आएगा बेटा. इलेक्ट्रिकल मेजरमेंट्स में क्या आएगा? मेजरिंग इंस्ट्रूमेंट्स आएगा. measuring instruments, in measuring instruments what we are going to get? We are going to get PMMC, moving iron, dynamometer, type wattmeter, next energy meter, इलेक्ट्रोस्टैटिक वोल्टमीटर, और उसके साथ साथ ब्रिड्जेस. ब्रिड्जेस में एसी ब्रिड्जेस, डीसी ब्रिड्जेस, पोटेंशियोमीटर्स, इंस्ट्रूमेंट ट्रांसफार्मर्स, इंस्ट्रूमेंट ट्रांसफार्मर में अगेन टू टाइप, करंट ट्रांसफार्मर एंड पोटेंशियल ट्रांसफार्मर, एंड वेरी रेयरली error analysis. Error analysis is a common topic. Power measurement, of course it comes here, dynamometer one, power. So this is what our syllabus. Odisha से है, nice, very good. साक्षी राजपूत गुड मॉर्निंग. ऐसा क्लास मॉर्निंग सुबह सुबह क्लास है तो वो मजा, असली मजा है. सुबह सुबह आप भी जो भी करना चाहते हैं सुबह सुबह करो. जो वॉकिंग करना चाहते हैं, जो जॉगिंग करना चाहते हैं, जो प्रेयर करना चाहते हैं और मेडिटेशन करना चाहते हैं, जो भी करना चाहते हैं सुबह सुबह स्टार्ट करो. उसका फ्रेश माइंड रहता है. फ्रेश माइंड से जो भी काम करते हैं वो रिजल्ट बहुत अच्छा रहता है. अगर आपने कोई ना कोई सब्जेक्ट स्टार्ट करना है, पढ़ना स्टार्ट करना है, सुबह सुबह स्टार्ट करो. ओके माय डियर, चलो, नाइस टू सी यू ऑल. चलो, सो अगर आपने अभी स्टार्ट कर रहे मेजरमेंट्स, हाउ मेनी ऑफ यू आर स्टार्टिंग द मेजरमेंट्स नाउ माय डियर? हाउ मेनी ऑफ यू आर स्टार्टिंग द मेजरमेंट्स नाउ? अब तक आपने मेजरमेंट स्टार्ट नहीं किया सर, अब तक हमने मेजरमेंट स्टार्ट नहीं किया. कौन स्टार्ट नहीं किया गेट के लिए? अब तक मेजरमेंट्स कौन स्टार्ट नहीं किया? प्रिपरेशन. Who has not started the measurements till now? Who has not started the measurements till now? So अगर आपने मेजरमेंट स्टार्ट नहीं किया अब तक, ये क्लासेस आप रेगुलरली अटेंड करने की कोशिश कर जाओ. ये क्लासेस से आपको क्या होगा ना, डेफिनेटली आपको थोड़ा सा पुशअप आ जाएगा। एंड जो मैंने दे रहा हूं, ब्लूप्रिंट दे रहा हूं, फॉर्मुलास दे रहा हूं, उसके ऊपर आपके पास गेट पीवीक्यू का बुक रहता है, गेट पीवीक्यू का, गेट का जो भी मटेरियल रहते हैं, फटाफट स्टार्ट करें। मेजरमेंट्स आप 10 दिन में कंप्लीट कर सकते हैं। 40 आवर्स में आप, अगर आपने डेली 4 घंटे बैठा, डेली 4 घंटे 5 घंटे मेजरमेंट्स पर कोशिश करो, 10 दिन में आपका मेजरमेंट्स हो जाएगा। क्योंकि एक एक टॉपिक को 2-2 घंटे पे पढ़े तो मेजरमेंट्स कंप्लीट हो जाएगा। आपके पास बहुत अच्छा मटेरियल होना है, एकदम बढ़िया मटेरियल होना है। मटेरियल हो तो ये यस। सो प्लीज नोट डाउन द सिलेबस बेटा। ये है हमारा बेसिक सिलेबस। एक्चुअली इसमें सब टॉपिक्स रहता है। फॉर एग्जाम्पल पीएमएमसी बोलो तो परमानेंट मैग्नेट मूविंग कॉइल, उसमें कुछ सब टॉपिक्स रहता है, लाइक रेंज एक्सटेंशन ऑफ पीएमएमसी एज अमीटर, रेंज एक्सटेंशन ऑफ पीएमएमसी एज अ वोल्टमीटर। मूविंग आयरन में सब टॉपिक्स रहता है, रेंज एक्सटेंशन ऑफ मूविंग आयरन। पावर मेजरमेंट टॉपिक्स रहता है, स्टार मॉडल, डेल्टा मॉडल, 2 वाट मीटर मेथड, ओके, पावर फैक्टर मेजरमेंट। सो एनर्जी मीटर, पावर मेजरमेंट, इलेक्ट्रोस्टैटिक वोल्टमीटर, करंट ट्रांसफार्मर, पोटेंशियल ट्रांसफार्मर, उसमें आपको थोड़ा सब टॉपिक्स भी रहता है। नेक्स्ट इलेक्ट्रॉनिक मेजरमेंट्स इज वेरी शॉर्ट सिलेबस। फर्स्ट कम्स द क्यू मीटर, नेक्स्ट कम्स द डीवीएम, डिजिटल वोल्टमीटर, नेक्स्ट कम्स द सीआरओ, कैथोड रे ऑसिलोस्कोप। इसमें बहुत इंपॉर्टेंट है फेज मेजरमेंट एंड फ्रीक्वेंसी मेजरमेंट। फेज मेजरमेंट एंड फ्रीक्वेंसी मेजरमेंट हमेशा हमको इसमें से क्वेश्चंस आता है लिसेजस पैटर्न्स से, लिसेजस पैटर्न्स बोलते हैं, जिसके ऊपर क्वेश्चंस आने की चांसेस ज्यादा है। ये गेट के लिए नहीं है, नॉन गेट के लिए। अगर आपने स्टेट लेवल कोई ना कोई इलेक्ट्रिसिटी बोर्ड एग्जाम्स लिख रहे, सपोज इफ यू आर राइटिंग कोई ना कोई स्टेट लेवल इलेक्ट्रिसिटी बोर्ड पेपर्स, देन आल्सो दिस विल बी सुटेबल। नेक्स्ट कम्स, दैट्स इट, दीज आर द मेजर टॉपिक्स माय डियर। DVM, cathode ray oscilloscope. Error analysis is a common topic. So all of you are clear now about the syllabus. Let us start the first topic, PMMC. So my dear students, before going for the setup, so this is the different types of instruments. If you see the different types of instruments, my dear, different types of instruments में क्या क्या है आपके पास? PMMC है, permanent magnet moving coil. So it is suitable only for DC measurement, DC current and DC voltage. Next comes the moving iron, my dear. Moving iron is suitable only for DC as well as AC. Next comes the electro dynamometer. Dynamometer, it is suitable for both DC and AC. Next, hardware suitable for both DC and AC. Electrostatic suitable for DC and AC. Rectifier type suitable for DC and AC. Hall effect suitable for DC and AC. Induction type suitable for, sorry, it is for AC. DC energy meter, DC as well as AC. Energy meter, DC energy is also possible, AC energy is also possible. Okay my dear, chalo, let us start the first topic. Rohan Markanda, सर नोट्स कहां मिलेंगे? क्लास होने के बाद आपको नोट्स मिलेगा बेटा। चलो लेट अस स्टार्ट द फर्स्ट टॉपिक, पीएमएमसी। पीएमएमसी का यही कंस्ट्रक्शन है बेटा। सो दिस इज द कंस्ट्रक्शन, जस्ट गो थ्रू फॉर अ सेकंड, फॉर अ मिनट, जस्ट गो थ्रू दिस इंस्ट्रूमेंट। देयर इज अ परमानेंट मैग्नेट, परमानेंट मैग्नेट के बीच में एक कॉपर कॉइल है विच इज वाइंडेड एंड विच इज हैविंग अ स्पिंडल। टू द स्पिंडल देयर इज ए स्प्रिंग अटैच्ड, to the spindle there is a spring is attached. क्लास होने के बाद आपको क्लास मिलेगा, क्लास होने के बाद आपको मिलेगा बेटा, क्लास होने के बाद जरूर आपको मिलेगा। Yeah, in electrical it comes for only 3 to 4 marks. Sir, how many days take to complete this subject? How much marks question come from measurement? आग लगा दूंगे भाई बेटा, आप थोड़ा फाइल में रखो. See dear students, measurements actually गेट में थोड़ा सा कम वेटेज आ रहा है. For electrical students it is 3 to 4 marks. See, for electrical students the weightage. So if you take the electrical, for electrical it will be around 4 marks, but for instrumentation it will be 8 marks. This is the tentative weightage, but sometimes it will be moving differently also. Okay, va? Chalo. If you see this PMMC, in PMMC we are having a set of components. What are the components we have? We have a permanent magnet. First of all, this permanent magnet is made by material 𝐂𝐤𝐿𝐿. PMMC stands for, you should understand the terms. Magnet permanent है, temporary नहीं है. There will be one fixed instrument, there will be one fixed component, there will be one moving component. इसमें permanent magnet is fixed, moving coil is the moving component. So permanent magnet, moving coil. So moving type is coil, fixed is permanent magnet. Okay, va? Permanent magnet made by 𝐂𝐤𝐿𝐿. Next, winding or the copper coil which is suspended, that is made by copper. Springs, phosphorus bronze. Next, pointer, aluminum. Cylinder coverage, or ferrous. So my dear students, there is a permanent magnet like this. So this is the permanent magnet. So in the permanent magnet there is a moving coil is suspended. So there is a moving coil suspended like this. There is a moving coil suspended. So this moving coil is suspended to a spindle. So if you see the picture, so this is our spindle. The spindle will be like this. The spindle will be like this. To the spindle there will be a spring like this. Okay na? And there is our copper 1 ton. There will be many turns like this. There will be many turns like this, and which is having a aluminum frame coverage. Aluminum frame coverage, and which is surrounded by a cylinder coverage like this. Cylinder coverage like this. And for this we have a pointer. This is a pointer. And this pointer is having a scale. Okay, so from this हमारा DC current आ रहा है. So that will go to this copper. And this is connected here, and this is going to outside. So बीच में ये हमारा नॉर्थ पोल साउथ पोल का अरेंजमेंट रहेगा. परमानेंट मैग्नेट, this is the north pole and this is the south. So there are certain reasons for each and every material. There is a certain reason. See, डायग्राम एंड डेरिवेशन आपके लिए इंपॉर्टेंट नहीं है, आपके लिए फॉर्मूला इंपॉर्टेंट है. ओके, फॉर ईच एंड एवरी मेजरिंग इंस्ट्रूमेंट देयर आर 3 टॉर्क्स. डिफ्लेक्शन टॉर्क, ऑलवेज रिमेंबर देयर आर 3 टॉर्क्स. डिफ्लेक्शन टॉर्क, controlling torque, and damping torque. So deflecting torque makes the pointer to move from left to right. Deflecting torque makes the pointer to move left to right. Controlling torque makes the pointer to move right to left. Because if current enters, because of the current there is a magnetic flux already between this, so there is a magnetic flux, lines are cutting here already. So there is a magnetic flux. Simply I will tell you, current carrying, current direction ऐसा है, this is a current direction, current का direction ऐसा चल रहा है, this is a current. So when a current carrying conductor placed in 90 degrees magnetic field, when a current carrying conductor placed in 90 degrees magnetic, then there is a force. So according to the force, it will deflect. So the deflection torque is given by an expression. The deflecting torque is given by an expression. Always remember, for PMMC, so I will give a table, my dear. Why? Because it is a YouTube class. In YouTube class, we are not going to derive the expressions. It is not our comprehensive course. Exam के लिए क्या चाहिए वो बताऊंगा मैंने. So we'll take a table. Okay, va? We'll take a table. In this table, I will write the name of the instrument, type of the instrument, deflection torque, controlling torque expression. So first write the name of the instrument. All of you have a cup of tea. सुबह सुबह हम हमेशा एक चाय पी के क्लास को आना है, माइंड रिफ्रेश रहता है. So this is what we call deflection torque, this is what we call controlling torque. For PMMC, deflection torque का expression है for PMMC. Anybody can tell me what is the expression for PMMC? For PMMC, the deflection torque expression is BINA, B-I-N-A. Controlling torque expression Kc theta. Moving direct of I square dl by d theta. This is Kc theta. Dynamometer I square dm by d theta. This is Kc theta. This is half v square dc by d theta. This is Kc theta. Please note down. Just note down for 1 minute. Noted, my dear. So first, easy to remember, for PMMC, this one you can remember like this, bina. Okay. So I square dl by theta, moving iron is an inductive type instrument, that's why dl by d theta. Dynamometer is a mutual inductance type instrument, that's why dm by d theta. Electrostatic voltmeter is a capacitive type instrument, dc by d theta. Try to remember these formulas. Once again I am repeating. Moving iron is inductive type instrument, dl by d theta. Dynamometer is mutual inductance type instrument, dm by d theta. Electrostatic voltmeter, capacitive same instrument, dc by d theta. Okay, my dear? Noted? Chalo. Try to answer this question now. IIT दिल्ली 2004 का सवाल है. हाँ, ऑलमोस्ट फॉर्मूला बेस्ड क्वेश्चन आएगा, आपको इजी होगा, वह बिकॉज 3 to 4 मार्क्स में आपको फॉर्मूला बेस्ड क्वेश्चन ही आएगा. ब्रिड्जेस पर थोड़ा नेटवर्क का कॉन्सेप्ट घुमा के, थोड़ा मेजरमेंट्स एंड नेटवर्क्स, मेजरमेंट्स एंड एनालॉग सर्क्यूट्स, ऐसा आएगा. हाय गोल्डी, कहां से हो? आदर्श राज. Answer please. फटाफट सॉल्व करेंगे. यहां a moving coil of a meter has 100 tons. It is having 100 tons. N is equal to 100 tons. N is equal to 100. Length and width L into B, 10 mm cross 20 mm, which is nothing but area 200 mm square. Next, it is positioned in a uniform radial flux density of 200 millitesla. 200 millitesla. The coil carries a current of 50 milliamperes. The current is 50 milliamperes. The torque on the coil is dash. Deflection torque is bina. B stands for magnetic flux density, I stands for the current, N stands for the number of turns. So all multiply karo, that is answer. This is 200 into 10 power minus 3 current is 50 into 10 power minus 3. N is number of turns, that is 100. Area is 200 mm square, that is 200 into 10 to the power of minus 6. Okay, so simplify करो, कितना आएगा चेक करो. So 1 2 3 cut. 1 2 3 4 5 cut. So minus 1. So 2 into 10 power minus 3, 10 power minus 1, 10 power minus 4. 2 into 10 power minus 4. The 200 micronewtons. Option A is the right answer, right? Option A is the correct answer. 200. See, इतना simple question आने के बाद भी units of torque will be Newton meter. So 200 micronewton meter is the answer. इतना simple question आने के बाद भी आपने mistakes किया. That is what gate is all about aptitude, graduate aptitude test. आप सोचते हैं आराम से कर सकते हैं, सिंपल की फार्मूला है, फटाफट कर सकते हैं, वही चक्कर में वही प्रेशर में आप गलत कैलकुलेशन करते हैं. सिंपल क्वेश्चन यू हैव मिस्ड. दोस पीपल दोस हु हैव टोल्ड द आंसर सी, मिस्टर ग्रोथ, मिंदा, गोल्डी, सो ये लोग ऑप्शन सी बताया, सो उसके लिए नेगेटिव मार्किंग भी है. सो माय डियर स्टूडेंट्स, मेजरमेंट्स का क्वेश्चन ऐसा ही होगा, सो डोंट बी इन ट्रैप. या कैन यू आंसर दिस क्वेश्चन? IIT खड़गपुर 2014 का सवाल है. IIT खड़गपुर 2014 का सवाल है. फटाफट प्रॉब्लम्स कर रहा हूं मैंने. YouTube का सेशन में तीरी नहीं बोल रहा हूं मैंने. गेट के लिए जो चाहिए वो कर रहा हूं मैंने. यस, इट इज ए NET टाइप क्वेश्चन, मुझे आंसर चाहिए. आपके पास पहले ही मैंने फॉर्मूलास दिया PMMC का, डायनामोमीटर का. भैया या इस प्रॉब्लम में क्या दिया है भैया? देखो, द DC current flowing a circuit is measured by two ammeters. One is the PMMC, and other one is the electrodynamometer. Connected in series. The PMMC meter contains 100 tons, so N is given as 100. In the coil, the flux density in the air is 0.2 Weber per meter square, 0.2 Weber per meter square. Area of this coil is 80 mm square, 80 into 10 to the power of minus 6 meter square. The dynamometer ammeter has a change in mutual inductance with respect to deflection. What is this? Can anybody tell me? What is this 0.5 millihenry per degree? दिस इज रिलेटेड टू व्हाट, दिस इज रिलेटेड टू डायनामोमीटर. सो मैंने ऑलरेडी आपको डायनामोमीटर का फॉर्मूला दिया है. कहा दिया डायनामोमीटर का फॉर्मूला? यहां आपको फॉर्मूला दिया है. These are formulas I have given. Even though we are not discussing the dynamometer construction, इस YouTube क्लास में कंस्ट्रक्शन की जरूरत नहीं है. कंस्ट्रक्शन आप पढ़ सकते हैं. कुछ एक कोई भी मेजरिंग इंस्ट्रूमेंट वो कॉमन फैक्टर क्या है ना, डिफ्लेक्शन टॉर्क के लिए एक मैकेनिज्म रहता है, कंट्रोलिंग टॉर्क के लिए और एक मैकेनिज्म रहता है. दैट्स इट. दैट मैकेनिज्म यू कैन स्टडी. डिफ्लेक्शन टॉर्क से हम रिलेटेड टू डिफ्लेक्शन टॉर्क इन्वॉल्व्स इंटरेक्शन ऑफ द करंट विथ फ्लक्स. कंट्रोलिंग टॉर्क इंटरेक्ट्स विद स्प्रिंग कांस्टेंट. That is the only thing that you have to focus. जल्दी से जल्दी प्रॉब्लम को जाओ. So moving iron डायनामोमीटर का फॉर्मूला क्या है? I square dm by dt theta, because it is a mutual inductance type instrument. So let us go for the problem now. Let us go for the problem. Okay. Yeah. So I square dm by dt theta is given, my dear, in the question. I square dm by dt theta. Sorry, sir. Dm by dt theta is given. In the problem, what is given, my dear? dm by dt theta is given as 0.5 millihenry per degree. The spring constants of both the meters are equal. So Kc and Kc both are equal. The value of current at which the deflections of the two meters are same. Deflection here is same. So how to solve this problem, my dear? How to solve? See here, deflection torque is equal to bina, controlling torque is equal to Kc theta, where K is the spring constant, theta is the deflection for PMMC. So at steady state, deflection torque is equal to controlling torque, bina is equal to Kc theta. So theta is equal to bina by Kc. Next, deflection torque is equal to I square dm by d theta. Controlling torque is equal to Kc theta. At steady state, Td is equal to Tc. I square dm by d theta is equal to Kc theta. Theta is equal to I square by Kc into dm by d theta. Is asking at which the deflections are equal. So if I equal deflections, if I write bina by Kc is equal to I square by Kc dm by d theta, Kc gets cancelled, 1I gets cancelled. So what is the answer? I is equal to B into Na by dm by d theta. So what is the B? 0.2. What is the N? 100. What is the A? 80 into 10 power minus 6 whole divided by dm by d theta 0.5 millihenry. Please tell me the answer, my dear. 3.2 amperes आ रहा है. गोल्डी, चरण, विनय सिंह 2 amperes आ रहा है, 3.2 amperes आ रहा है. जल्दी बताओ. कैल्सी यूज करो बेटा, थोड़ा कैल्सी यूज करो. पॉइंट 2 into 100 into 80 divided by 0.5. 10 power minus 6 plus 3 minus 3. 3200 into 10 power minus 3. 3.2 amperes are. So the right answer for this question here is 3.2 amperes. Okay वाह बेटा? So right answer is. मजा आ गया? IIT खड़गपुर का सवाल है 2014 का. देखो रोहन जी इंस्ट्रूमेंटेशन के बच्चे हैं. सूरज राय, आदर्श राज, उमेश ठाकुर, वेरी गुड. जल्दी से जल्दी जाएंगे और एक टॉपिक को. व्हाट इज आंसर? A PMMC voltmeter is connected across a series combination of a DC voltage source V1 is equal to 2 volts and AC voltage source V2 of t is equal to 3 sin 4t. The PMMC reads as dash. आंसर बताइए बेटा. PMMC will measure AC. PMMC is not suitable for AC. Okay, do it. Do. Yeah, 2 volts because PMMC is a DC type instrument. The reason is, if you take this arrangement जो मैंने explain कर रहा है आपको PMMC का, this one, if you see this picture, PMMC cannot, this moving coil cannot deflect that much fast for a frequency AC signal, because whenever the deflection happens, this copper coil will deflect like this. Suppose AC signal means both positive and negative both will be coming now, so we will be expecting for positive signal there is a deflection, for negative signal there is opposite deflection. So negative signal there is opposite deflection, so then the pointer should come back. If it is a low frequency like 0.1 there may be a possibility, but generally we don't have AC signal very very low frequency. 50 Hz 50 Hz बोलो तो क्या है, एक सेकंड में 50 pulses 50 times, so it cannot, the pointer cannot deflect, so DC measurement only possible. That's it. So even though very very clear concept, but sometimes these type of questions are asked in the exam, so that's why the answer is 2 volts. For suppose moving iron is asked, moving iron can measure both DC as well as AC. So if that is the case, so we have to take square root of, this is for moving iron, square root of 2 square plus IRMS. Moving iron will measure the RMS value, so that is 3 by root 2 whole square. So it will be root 4 plus 9 by 2, 4.5. So like this, root 17 by root of 17 by 2. Okay, this should be root 2. So option D for moving iron. For moving iron option D होगा, but for DC this is the answer. This is for moving iron, this is for PMMC. Okay, वाह, चलो. Now what is the answer for this question? IIT Kharagpur 2006. जल्दी बताओ. A current of -8 plus 6 root 2 sin omega t plus 30 is passed through 3 meters. There are center 0 PMMC meter, true RMS meter and a moving iron instrument. The respective readings will be dash. See, 3 meters, center PMMC, moving iron, true RMS and moving iron. So true RMS -8 plus, so what is I of t? That is given as -8 plus 6 root 2 sin of something omega t plus 30. So true RMS, what it will measure? It will measure IRMS. So it will measure IRMS. So what is the IRMS? That is square root of -8 whole square plus 6 root 2 by root 2 whole square. That is root of 64 plus 36. So 10 amperes. Moving on also IRMS. So 10 amperes. Center PMMC means what? That means at center it is 0. This side positive reading. This side negative reading. For normal PMMC, it is different story. Center PMMC means different story. Okay, va? Center PMMC means different story. Center PMMC means at the center it is 0. The deflection to one side is positive reading. Deflection to other side is a negative reading. So it is going to measure -8 amperes here. So the answer is -8, 10, 10. So the right answer for this question -8, 10, 10. Option C will be the answer. Sir, I am from first year. How should I start my preparation? I am from electrical branch. Which subject should I start first? ऋषभ गुप्ता, आप पहले बीटेक पर फोकस कर लो. ऋषभ गुप्ता जी, आप पहले बीटेक पर फोकस करो, बीटेक का लाइफ एंजॉय करो. आपको इतना जल्दी गेट के लिए प्रिपरेशन करने की जरूरत ही नहीं है. आप कॉलेज में जाओ, कॉलेज में बच्चियों से आराम से आपका लाइफ एंजॉय करो. फर्स्ट ईयर से गेट का प्रिपरेशन जरूरत ही नहीं है. आप सेकंड ईयर के बाद थर्ड ईयर में एंटर होते ना, उस समय आपका गेट प्रिपरेशन चालू करो. आप पहले कॉलेज में क्या क्या प्रैक्टिकल्स है, क्या क्या लैब्स है, उस पर ध्यान रखो. फर्स्ट ट्राई टू गेट द बेसिक्स फ्रॉम द फर्स्ट ईयर. ओके, जो भी यूनिवर्सिटी हो, मुंबई यूनिवर्सिटी हो और उत्तरांचल यूनिवर्सिटी हो, जो भी यूनिवर्सिटी हो, आप पहले स्टडी पर फोकस करो. इतना जल्दी की जरूरत ही नहीं है बेटा. ओके, चलो माय डियर, लेट अस गो फॉर द नेक्स्ट टॉपिक, दैट इज the range extension of PMMC. So what is the next topic? That is a range extension of PMMC. So PMMC can be suitable as a ammeter. PMMC can be suitable as a voltmeter. See here, PMMC as ammeter range extension. So if you see my dear, so this is our PMMC instrument. So this is our PMMC. So this is our ammeter. This is our RM. This is our RSH. So this is our I. Okay, the range extension. Can anybody tell me the formula? क्यों भी ब्रांच हो बोला यार ऋषभ गुप्ता, क्यों ऐसा बात करते? स्टार्ट करें तो आप आराम से पीडब्ल्यू का यूट्यूब क्लासेस से पढ़ो बस. पीडब्ल्यू का यूट्यूब क्लासेस से पढ़ो बस. ओके, पहले सब्जेक्ट नेटवर्क से स्टार्ट करो. पहले सब्जेक्ट नेटवर्क से स्टार्ट करो बेटा. ऐसा होता है बच्चों को जो आंसर चाहिए वही आंसर मिलना है. जो सच चाहिए वो नहीं मिलना है उसको, जो आंसर चाहिए वही मिलना है, then they will be comfortable because you are in first year, so you should know what are the subjects, what are the basics. You should know first what is diode, what is electronics, what is current, so what is networks, what is the programming, these things are there. So बच्चों को जो चाहिए वही सुनते, जो आंसर चाहिए वही आंसर चाहिए, जो सच है वो नहीं चाहिए. If you are in the first year, then focus on your college. सेकेंड ईयर के बाद आपको एटलीस्ट सम 30 to 40% सब्जेक्ट्स विल बी कवर्ड इन योर एकेडमिक्स, देन आराम से आप गेट का प्रिपरेशन स्टार्ट कर सकते हैं. दैट्स हाउ हमारा चाइल्डहुड से ऐसा हो गया हमारा जिंदगी. 10th क्लास पढ़ते हैं उसी समय आईआईटी के बारे में सोचते हैं, आईआईटी जेईई में एंटर होता है उसी समय इंजीनियरिंग के बारे में सोचते हैं, इंजीनियरिंग फर्स्ट ईयर में एंटर करते हैं उसी बाद मास्टर्स में सोचते हैं. ऐसा पहले प्रेजेंट में जियो, उसके बाद फ्यूचर पर ध्यान रखो. ऐसा हो गया पूरा. Simple my dear. Normal PMMC reading starts from 0 to positive. Center PMMC is having 0 to positive right side, 0 to negative left side. अगर normal PMMC है तो positive reading only आएगा 8 amperes. ओके थैंक यू. चलो पीएमएमसी अम्मीटर रेंज एक्सटेंशन इसको कैसे करना है. देखो बेटा, दिस इज आई. सो जनरली पीएमएमसी इज हैविंग ए कॉपर कॉइल, राइट. द कॉपर कॉइल इज नथिंग बट R is equal to rho L by A. In number of turns are there, so it is having a meter resistance. So that's why the meter resistance will be coming in series. जनरली करंट का एक्सटेंशन करना है, रेंज को एक्सटेंड करना है बोलो तो क्या है, उसको अल्टरनेटिव पाथ प्रोवाइड करना है. So what is the alternative path? हम पैरेलल में एक शंट रेजिस्टेंस डालते हैं which is very very less. So then what happens, a part of the current will come here. This is the shunt resistance. So this is a meter current IM. Okay my dear. So if you take these two parallel branches, this is the VSH, this is the VM. So if I take this VM and VSH, this is the VM and this is the VSH. Am I right? Voltage across this meter, voltage across this shunt, both are parallel. Voltage across the meter if I take, that is IM into RM. Voltage across the shunt if I take ISH into RSH. So from this if I take RSH is equal to IM into RM divided by ISH. So ISH what I can write? So RSH is equal to IM into RM ISH can be taken as I minus IM. Am I right? Why? Because this ISH is a split of this I. So if I take this IM out, this will be I by IM minus 1. So यहाँ ये कट हो जाएगा. So now the shunt resistance formula will become as RM by N minus 1. So which is called the multiplying factor. So where M is the multiplying factor. Please note down. Please note down my dear. These formulas, measurements is all about formulas. Okay ba? Thank you. Welcome. Next comes PMMC, voltmeter range extension. All of you clear? All of you have noted? Enough. Chalo. Can anybody tell me what will be the formula for the PMMC voltmeter? Excellent, excellent. Where to get this PPT, sir? An app. Okay, sir, your lecture for CAO, for EE, ESC का अलग सिलेबस है, गेट का अलग सिलेबस है भैया. मैं गेट का जो पढ़ रहा हूँ, जो गेट के लिए है, ESC के लिए जो रिकॉर्डिंग दे रहा हूँ वो ESC के लिए. ESC का अलग सिलेबस है, गेट का अलग सिलेबस है. सी वो ये. Chalo, let us go for the voltmeter range extension. So if you want to take the voltmeter range extension, so this is our meter resistance, this is our IM, and this is our series resistance. This is our series resistance. The series resistance is RSC. So this is our V. This is our VM, this is our capital V. So if I take the V by VM, V will be I into RSC plus RM, VM will be IM into RM. दोनों equal है. Why? Because both are equal. The same current is traveling, yes or not? So that's why these two we can cancel. So if you take this as multiplying factor, this I can take as RSC by RM plus 1. So from this what I can write, M minus 1 is equal to RSC by RM. So the series resistance is equal to RM into M minus 1. So this one is called multiplying factor. M is the multiplying. Rohan, how to remember this? How to remember this? I told you the trick, Rohan. I told you the trick, Rohan. Hit the like button. Thank you, Rohan. How to remember this? For voltmeter, the resistance will be in series. That's why M minus 1 will come nearby, series. For ammeter, shunt resistance means down. Shunt resistance is down. That's why M minus 1 will come down. That is a technique. Just like bina is a technique, mera bina, tera bina. Bina is a technique to remember in our deflection torque. Here is a technique. For ammeter, RSH comes down, so M minus 1 comes down. For voltmeter, series resistance comes in series, so M minus 1 comes in series. Clear beta? Chalo. Now let us solve some questions. Answer this question. 25 ohms. ओके, आंसर आ गया. फर्स्ट ऑफ ऑल क्वेश्चन में क्या दिया देखना है. क्वेश्चन में अम्मीटर दिया, सो डायरेक्टली यू कैन गो फॉर अम्मीटर डायग्राम, दैट्स इट. क्वेश्चन में क्या दिया आप देखना है पहले, सो अम्मीटर का डायग्राम डालो, दैट्स इट. A 100 microamperes ammeter has an internal resistance of 100 ohms. For extending its range to 500 microamperes, the shunt resistance is asking. So RSH is equal to RM by M minus 1, where M is equal to I by IM minus 1. So meter resistance कितना है 100 ohms, the whole divided by I कितना है 500 microamperes, IM कितना है 100 microamperes minus 1, so 5 minus 1 4, so answer is coming as 25 ohms. Answer this. A galvanometer with a full scale current of 10 milliamperes has a resistance of 1000 ohms. The multiplying factor, the ratio of measured current to galvanometer current of a 100 ohm shunt. So RSH is equal to RM by M minus 1. A galvanometer with a full scale current of 10 milliamperes. So IM is equal to 10 milliamperes. Has a resistance of 1000 ohms. So RM is equal to 1000 ohms. The multiplying factor M, that is equal to I by IM, okay, of a 100 ohms shunting resistance is what? So RSH is given as 100 ohms. So you can simply substitute this 100 ohms, meter is 1000, M minus 1. Very simple question. Answer this question. फटाफट। IIT बॉम्बे 2005 का सवाल है। A DC ammeter has a resistance of 0.1 ohm and its current is 0 to 100 amperes. The range is to be extended to 500 amperes. The meter requires the following shunt resistance. IIT बॉम्बे 2005 का सवाल है। उमेश ठाकुर जल्दी बताओ आंसर फटाफट। A DC ammeter has a resistance of 0.1 ohm. So very clearly given Rm is equal to 0.1 ohm, current ranging from 0 to 100 amperes. That means the Im is 100 amperes. Range is extended to 500 amperes. आपको प्रैक्टिस होना है इसलिए मैं ये क्वेश्चन दे रहा हूँ। शंट रेसिस्टेंस पूछ रहे हैं। RSH is equal to Rm by M minus 1, that is M बोलो तो I by Im minus 1. So RSH, what is the Rm? That is 0.1. What is the I? 500 divided by Im 100 minus 1. So 0.1 divided by 4, 1 by 10, 0.025 ohms. Option C is the right answer. Answer this question. Answer option. Okay, a ammeter has a current range Im 5 amperes, internal resistance Rm 0.2 ohms. In order to change the range to 25 amperes, RSH is asking. IIT मद्रास 2019 का सवाल है, जल्दी बताओ। A moving coil instrument having a resistance of 10 ohms gives full scale deflection when the current is 10 milliamperes. What should be the value of series resistance so that it can be used as a voltmeter for measuring the potential difference up to 100 volts? So first it was ammeter. So when it is ammeter, we have IM and we have RM, we have RSH. Now we want to convert that into voltmeter. So RSC, this is IM, this is RM. A moving coil instrument having a resistance of 10 ohms, so this is 10 ohms, gives a full scale deflection 10 milliamperes. This is 10 milliamperes. What should be the value of series resistance? He is asking. That it can be used as a voltmeter for measuring a potential difference of how much? 100 volts. So first of all, from this we can find out the VM. So what is the VM? That is IM into RM, 10 into 10 power minus 3, RM is 10. So 100 millivolts. So series resistance RSC is equal to RM into M minus 1. M is equal to capital V by small vm minus 1. मीटर रेजिस्टेंस कितना है? RM 10, कैपिटल V कितना है? 100. ये 100 मिली है, 100 into 10 power minus 3 minus 1. So 1000 minus 1, 999, 9990 ohms. So the answer is 9990 ohms. Am I right? Very good question. ऑप्शन ए भी तो सकरट सोच कैसा? विच क्वेश्चन? दिस वन लक्ष्मण सारी सर, प्रीवियस वाला क्वेश्चन भी ऑप्शन ए भी तो करेक्ट हो सकता है. Which question? अरे लक्ष्मण, लखान सैनी, क्या ऑप्शन डी है ना? लाइक मारो भैया, जितने लोग लाइव में लाइक मारो. सेशन इतना लोग दे रहे हैं, 39 पीपल आर वाचिंग, 39 पीपल आर वाचिंग, केवल 5 लाइक्स है, ये अच्छा नहीं है. लाइक मारो, पुकट में आ रहे हैं, लाइक मारने की क्या है प्रॉब्लम? इमीडिएटली आई एम एक्सपेक्टिंग. अमीटर डी होगा, वोल्टमीटर बोलता है आंसर. ओके ओके ओके, लाइक मारो जल्दी से जल्दी, मुझे 40 काउंट दिखना है उधर. क्या है? केवल 5 लाइक्स है. चलो, let us take the theory topic, errors in PMMC. All of you like the button? Okay. Like मारो बेटा, like मारो. Excellent, thank you. 40 likes आ गया, thank you very much. See, these are the errors in PMMC. So theory topic है, there are notes, note करो. Cause of errors. What can be the errors in PMMC? Weakening of a permanent magnets due to aging of temperature effects. हमने जो परमानेंट मैग्नेट यूज कर रहे हैं ना, ऑलनिको मटेरियल, ओके, सो जो परमानेंट मैग्नेट हम यूज कर रहे हैं वो पीक हो सकता है टाइम पर, दैट मीन्स ओवर अ पीरियड ऑफ टाइम दैट परमानेंट मैग्नेट कैन बिकम वीक, ओके, दैट इज ड्यू टू टेम्परेचर इफेक्ट, ड्यू टू टेम्परेचर इफेक्ट दैट कैन बिकम वीक. Next, weakening of springs due to aging and temperature effects. Due to age and temperature effects, that also will become weak springs. Next, change of resistance of the moving coil with temperature. Yes, that is very very important. हमारा instrumentation में बहुत important है temperature. So these temperatures can affect the performance of every instrument. Generally, हमने copper winding use कर रहे हैं ना, copper winding. So this copper winding is metal. This copper winding is basically metal. Am I right? This copper winding is basically metal. So whenever you are using the metal, definitely क्या होता है? Metals are having positive temperature coefficient of resistance. As the temperature increases, the resistance also increases. As the temperature decreases, the resistance also decreases. So there is a possibility of some error. In the morning 25 degrees Celsius, suppose if it is operating, by the afternoon if the temperature of the room changes to 50 degrees Celsius, definitely that will affect the performance, wrong readings and everything. Next, that just these are theoretical information for your reference. Okay, wow. So these theory questions, this theory will be useful for IES actually. For IES and non-gate. Okay, that means if you are writing any exams like 𝐂𝐚𝐿, Transco at that time. Infinity. Ideal existence में नहीं रहता भैया, क्यों इसको देखना है? RSH should be very very low. If RSH is very very low, multiplying factor will be very very high. RSH is equal to RM, RSH multiplying factor is equal to I by IM na. Yeah, just I'm explaining so that you can note it. So 1 degree Celsius rise in temperature reduces strength of the springs by about 0.04% and reduces the flux density in the air gap by 0.02%. The net effect is to increase the deflection by 0.02%. That means the temperature can affect the springs performance, the temperature can affect the magnet performance. So इसको effect reduce करने के लिए हमने एक swamp resistance use करते हैं. That swamp resistance will be basically manganese material. So नहीं screen freeze नहीं हो गया भैया. Okay, चलो. Sometimes some questions will be coming like this. What is the answer for this question? These answers are wrong. Please answer this question. Answer this question. The current I of t passing through 10 ohms resistor as shown in figure A has a waveform as shown in figure B. Then the reading of the DC voltmeter connected across the 10 ohms resistor is dash volts. Can you tell me? So this is I average. PMMC measures always I average. So I average is equal to what? 12 plus 5 by 2, 17 by 2, that is 8.5 amperes. 8.5 amperes. So what is the V average? That is I average into resistance. So this is 8.5 amperes into R, that is 10. So the answer will become as 85 volts. Next question. गोल्डी, आपका एक्चुअल नेम क्या है? गोल्डी, आपका एक्चुअल नेम क्या है? The scale of a voltmeter is uniform, its type is dash. See, uniform scale, that means, see here, for moving iron, if you check, for PMMC, if you check, deflection torque is bina, controlling torque is Kc theta. So at steady state, if you write deflection torque and controlling torque both are same, so bina is equal to Kc theta, so theta is proportional to I. So the scale will be like this. Scale will be like a uniform. But whereas moving iron and other instruments, deflection torque is 1/2 I square dl by d theta, controlling torque is Kc theta, that means theta is proportional to I square. So now if I take the scale, the scale is like this. It is not uniform. So this is uniform. This is, in the beginning there will be crowded. Why? Because for smaller values this theta will be small, so in the beginning it will be crowded. In the middle it will be linear, and later on it is spacious. That means if current is 0.01 amperes, theta will be same almost. If current is 1 ampere, theta will be 1. If current is changing 2, 4, 5, then the spacious readings will come. So this is non-uniform scale. So uniform is only for moving coil, permanent magnet. This is non-uniform. This is non-uniform. This is non-uniform. Only this is a uniform scale. बराबर गोल्डिया, गोल्डी ब्राब्रा, what is that name यार? PM means done. चलो, answer this question. A 0 to 10 milliamperes PMMC ammeter reads 4 milliamperes in a circuit. Its bottom control spring snaps suddenly. So if the bottom control spring snaps suddenly, this is the current. The bottom control spring snaps suddenly, somewhere it snaps like this, then current cannot enter, deflection will be 0. ओह, मेरे क्लास को गैंगस्टर्स भी आ रहे हैं क्या है यार? ये मेजरिंग इंस्ट्रूमेंट्स पढ़ा के गैंगस्टर्स क्या करते रे? कोई बॉम्ब मैन्युफैक्चरिंग में ऐसा यूज करते क्या पीएमएमसी को? चलो, आंसर दिस. then also deflection will be zero, current का continuity नहीं रहता ना. volts full scale PMMC type DC voltmeter having a figure of merits. First of all, you should understand what do you mean by figure of merit. ये क्या figure है? Try to answer. आंसर क्या आ रहा है भैया? अरे यार सब भी मैं ही बता रहा हूं. सी 200 volts full scale 200 volts full scale PMMC type DC voltmeter. So if you see here, these are the two DC voltmeters. The full scale voltage is how much? 100 volts. Meter 1 and meter 2 having a figure of merit. Figure of merit is nothing but the sensitivity. Sensitivity is 10 kilo ohms per volt. That means the resistance offered for 1 volt display is 10 kilo ohms. Okay, so 10 kilo ohms per volt इसका sensitivity है, figure of merit, and figure of merit for this is 20 kilo ohms per volt. That means for what? The internal resistance of the meter to display 1 volt perfectly for this particular meter is 10 kilo ohms. So for 1 volt display, the resistance required is 10 kilo ohms. For 100 volts display, it will be 1000 kilo ohms. 1000 kilo ohms. Next here, for 1 volt, it will be 20 kilo ohms. For 100 volts, it will be 2000 kilo ohms. Do you understand? Now these two are connected in series. That means if you take their internal resistance, full resistance, this is 1000K and this is connected in series 2000K. And what is the series combination can be used to measure a maximum DC voltage of dash volts. So now if you take the inverse of this 1 by sensitivity, what we are going to get? Units check करके बताइए. 1 by sensitivity बोलो तो क्या आएगा? सूरज, राम, RM, रोहन. 1 by sensitivity बोलो तो units क्या होगा? किलो ohms per volt, volt per kilo ohms. Volt per ohm means ampere आएगा ना? So that is what we call as full scale deflection current. So that is what we call as full scale deflection current in 1. So that will be what? 0.1 by 10, 0.1 milliamperes. 1 by 10 kilo ohms per volt, 0.1 milliamperes. So that is the full scale current. Similarly, इसका inverse करो 1 by S2. So that is IFSD2. So 1 by 20 kilo ohms, that is 1 by 2 means 0.5, 0.05 milliamperes. Am I right? Am I right? So full scale deflection current to display 100 volts, the current required to display 100 volts for this particular meter is 0.1 milliamperes. The current required to display 100 volts here is 0.05 milliamperes. Is it clear, my dear? Yeah. Now when these two are connected in series, what is the net resistance? The net resistance will be 3000 kilo ohms. So 1000 plus 2000. 1000 plus 2000 kilo ohms. This is a voltmeter now. Am I right or not? That is the voltmeter. So this is our current. So when two voltmeters are in series, the minimum current will take. Am I right or not? When two voltmeters are in series, which current will consider? Networks ka question hai. When two voltmeters are in series, first voltmeter connection is full deflection is possible for 0.1 milliamperes. Next voltmeter is possible for full scale deflection of 0.05 milliamperes. When two voltmeters are in series, which current you will consider, Rohan, Suraj? Which current you will consider? Which current you will consider? So definitely the least current will consider 0.05. So if we consider the 0.05 milliamperes, then what is the V? 0.05 milliamperes into 3000K. So here the kilo ohms, the milliamperes gets cancelled. This is 5 into 10 power minus 2. This is 3 into 10 power 3. Am I right? So this is 15 into 10 power 1. So 150 volts is the right answer. That is the answer. Figure of merit is nothing but sensitivity of the voltmeter. How much resistance is required to display the voltage, that is represented in the figure of merit. Inverse of the figure of merit is nothing but current, full scale deflection current. मजा आ गया बेटा क्लास? कैसा लग रहा है क्लास? लाइक मारो भैया न्यू कमर्स. Chalo, now let us take some concepts of moving iron instrument. Moving iron instrument का concepts क्या है? Moving iron instrument is an inductive type instrument. It uses an electromagnet like this, okay, and there is an iron disc to the spindle. There is an iron disc like this. So this is the iron disc. So this is the electromagnet, we will call. This is the iron, moving iron. That's why we call moving iron. So whenever a current travels, Around the electromagnet, there is a magnetic flux. For a change in current of di, there is a change in flux d phi that attracts this iron disc. Then this iron disc will be moving deflection like this. So that can be given to a pointer. That is a mechanism, simply speaking. You can get the mechanism from any textbook. That's matter. That is doesn't matter. So definitely, this is for the deflection for positive. For deflection for negative also possible, it will go back. The more is the current, the more will be the change in current, the more is the change in flux, the more will be attracting force, force of attraction. Because of force of attraction, this iron disc will move by deflection theta. So that theta will be represented here. So coming to the formulas, deflection torque is equal to 1 by 2 I square dl by d theta. Controlling torque is equal to kc theta. At steady state, if we equal, theta is proportional to I square, which is called moving iron ammeter. And we also can be suitable as voltmeter, moving iron voltmeter. So it measures the RMS. So both AC and DC RMS measurements are possible. That's enough. You have to remember these formulas. आपको कुछ डेकोरेटिव आइटम्स चाहिए बोलो तो आप ले सकते हैं नेट से. So now if you take the range extension of moving an ammeter, so what is the difference for PMMC and moving iron? In PMMC we are having only resistance, with non-uniform scale. In PMMC we are having the only resistance, but here we are having the inductance also. So if you take this one, this is our IM, this is our RM. In addition to this, we'll be having the inductance also. This L. Understood, my dear? To extend the range, we have to attach a shunt component. The shunt component also should have both. So this is RSH and this is LSH. So this is the I, this is the ISH, this is the IM. So now if I am checking this, Vm is equal to VSH, this will be Im into Zm, this is ISH into ZSH, which can be taken as square root of Rm square plus omega Lm whole square. This is ISH square root of RSH square plus omega LSH whole square. Am I right? Yeah. So if I am taking Im into square root of Rm square omega Lm whole square is equal to ISH square root of RSH square plus omega LSH whole square. If you take the Im by ISH ratio, this will be RSH square plus omega LSH whole square, the whole divided by Rm square plus omega Lm square. Definitely for different frequencies, different readings will come. That is a frequency error in our moving iron. Omega is a frequency. For DC, omega is equal to 0. So then what happens? Im by ISH. Rohan, are you a paid student? Rohan Markanda, you are from instrumentation. Are you a paid student? You are already having the PW live class also you attended, right? So this is RSH square by RM square. Square gets cancelled. IM by ISH is equal to RSH by RM. So again same to same formula will come. So RSH is equal to RM into IM by ISH, that is I minus IM. So if you take IM out, I by IM minus 1. So IM gets cancelled. So the shunt resistance is equal to RM by M minus 1. So for DC this is the same. This is for AC. Similarly, you can take the voltmeter. So this is our RM, this is the IM, this is our RM, this is our LM, this is our meter, so this is our RSC, this is VM. Ready na? Oh, custom. This is our V. Same to same derivation you can do and tell me. Tomorrow you tell me the expression. Okay? Tomorrow you tell me the expression. Assignment I am there. What is the series resistance expression? Okay, so this is moving iron voltmeter. Now for today, tomorrow you tell me this RSC resistance formula. Yes, do it and come. Okay, I hope all of you enjoyed the session. Tomorrow we'll continue with dynamometer, wattmeter. Enough for today.